Okay. There's a difference. Mic and camera still on. Okay.
Yeah. But Shane is on mute, but I think that is intentionally.
It's interesting, Lisa, your virtual background blurs your wine glass.
It's just a blurred background.
Yeah.
It's not even a virtual one, but that's
Oh,
good.
okay.
Okay, that's good to know. This is Vivian coming in and she's muted and the camera is off. But she can hear us, I hope. Perfect. Thank you very much for the confirmation. We're going to give everybody some time and start in 3 minutes. One more minute until we get it going. Okie dokie, 3 minutes after the hour. Welcome everybody to our webinar, Optimize, Consolidate. And My name is Lisa Voigt. I'm the COO and SVP Sales of SVA Software Inc., being responsible for North America. Also, at the same time, I'm the head of IBM Red Hat Sales for SVA Global. And I just got appointed to that role on Monday of this week, so this is very new to me, but I'm more than excited, especially because SVA is the biggest business partner for IBM globally. Congratulations to the team. Let me introduce the speakers of today. A very, very warm welcome goes out to Bill. Bill is a legend, let's say, within the IBM network. He's with the company for, I think 35 years it is, when I remember correctly. Yeah. But what's really impressive to me, Bill is the chief architect for power microprocessors, and he holds more than 300 patents. That is such an impressive number. Congratulations, Bill. This is cool, and I'm very proud of you and us, especially for having you on today's webinar.
Thank you so much, Lisa.
Absolutely.
Good to be with you.
Thank you very much, and hi to Austin. And we also have Udo. Udo is our internal SVA legend for everything IBM Power. Udo's an IBM champion for how many years that nobody can count anymore. He leads the IBM Power Competence Center at SVA, being responsible for the global business there. He's been familiar with the evolution of IBM Power since Power 2. I think we're at 11 right now. And has worked with so many customers around the globe and brings in such a tremendous knowledge and business value. Udo, thank you very much. I know it's late where you are. I know it's a federal holiday in Germany tomorrow. Very much appreciate having you here. Thank you for joining.
Yeah, thank you for inviting me.
And then last but not least, we have our Rosario on the call. She's a senior technical consultant at SVA Software Inc., based in Atlanta. She collaborates with our business partners and customers to really help optimize the storage infrastructure and improve efficiency throughout the IT infrastructure. She has a tremendous amount of knowledge and expertise in everything that is storage, and she also works as in the pre-sales team, working on designing the storage solutions for our customers. Rosario, very warm welcome to you. You helped a lot preparing this webinar. I'm very glad you're here. Thank you very much to all the speakers of today. I'm not going to say much moving forward, but one thing, I hope that everybody had the opportunity to order their gift baskets well in advance. I got my one. I hope so you got yours as well. Please share with me, enjoy the next hour, enjoy your snacks, enjoy your zips, whatever you ordered. We very much appreciate having you here. Thank you and cheers.
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 Cheers. Okie dokie. Bill, we're going to start with you. Would you mind and talk us through a few IBM Power memory and processor architecture features and capabilities, and please also explain why they matter so much in practice?
Yeah, definitely. I'd love to. And really, there's so many areas, given our optimizations that we put in, which are really system-focused optimizations as opposed to piece part optimizations. And I think maybe, one that I'd like to touch on that is really one of my favorites is our memory architecture, especially if you compare. So what we got here, I know it's a detailed chart with a lot on it. I just really want to hit some high points here. If you look at the top half of the slide, that is a picture of a typical x86 server memory architecture. And then on the bottom, we contrast that with what does Power have for its memory architecture. And the first thing I want to draw your attention to is, over on the left side where we have the processor with the compute elements and things, we have the signaling resource. What is that? Well, that's how do you get the data in and out of the processor chip to memory. And one thing you'll see there with x86, because they're using this old-fashioned DDR signaling to talk all the way over to the memory, they use about 2/3 of all the processor signaling resource just to talk to memory. And that really limits them on how they can do other things like bandwidth at scale for so many of the system balance aspects. Whereas power on the bottom, you see we're only using about 1/3 of the processor signaling to talk to memory. But what's even more fantastic is when you look at how much bandwidth, how much capability you have to move data in and out, we have around 4 times as much bandwidth. So you see those really 16 really fat pipes on power compared to the 8 really skinny soda straws on x86. So we are able to access so much more memory at so much more bandwidth, but we're only using 1/2 of the signaling resource to do that. And so what that does, it not only gives us that bandwidth boost, but it gives us a huge capacity boost as well, because we're putting 32 DDR5 ports behind a single processor socket, where x86 maybe only puts 8. And so that's one aspect of the value of using our OMI signaling over DDR signaling. The other one, if we look on this chart, we also get reliability. So in an x86 system where you have these DDR signals coming all the way from the processor through the motherboard across the DIMM connector, which is the sort of scariest from a reliability standpoint, and then up onto the DIMM, it's just a signal integrity nightmare. And as the industry runs DDR speeds faster and faster, we run into more and more reliability problems there. Now, how do we address that on power? Well, with power, the OMI signaling is very resilient, it's replayable, it's packetized, it's steerable. So when we go over that dangerous DIMM connector, we're using OMI signaling, and we don't get to the DDR signaling until we're way over on the DIMM going a very short distance. So, these reliability elements, in addition to the fact that we put spare DRAM chips on the DIMM, it's a really key aspect of why power is so much more reliable than typical x86 servers, especially when you get into really large memory configurations for workloads like SAP HANA. And then finally, there's one more element I want to touch on here, not just the bandwidth and the capacity and the reliability, but if we can go to the next slide, the other beauty that we get here is in a typical x86 system, you're kind of shackled. You have your x86 processor, and you have whatever kind of memory that knows how to talk to. And you can't go from DDR4 to DDR5 memory without going from one processor to another, or vice versa. You go upgrade your processor, you're sort of forced to upgrade your memory with it. With power, on the bottom there, you see the connection between the DDR signaling and the DRAM, it's all contained on the DIMM, and the processor doesn't really care what kind of memory you're talking to. So that's why with something like Power 11, and especially with some of the supply chain issues around DDR5 memory, we can have a lot of agility there in saying, oh, you don't have to use DDR5 with a Power 11. We could create an offering where DDR4 gets used with Power 11. And in fact, we offer that in some of our offerings. So just another example of the agility and resiliency around our memory. So memory is one big thing, but there's so many more, and maybe in the next part of the discussion I'll touch on them as well. But so that's kind of my soundbite around one of my favorite aspects of the power systems.
Gosh, Bill, I love your slides. This is not your typical IBM slides. I very much appreciate that. And I have another question for you. So from an architecture standpoint, what do you think are the biggest IBM power advantages that help organizations optimize performance and, let's say, consolidate more workloads per system?
Yeah, and consolidation is key. So while the memory architecture with all that extra bandwidth and capacity plays a very important role in that, another key area, if we can go to the next slide, is you get right into our processor core architecture. And, whereas x86 puts 2 threads in every processor core, and there you see on the left side, that's kind of like trying to put a lot of cars on a 2-lane highway. With power, with our cores, we put 8 execution threads in every processor core. So whereas x86 has a 2-lane highway, it's kind of like we have an 8-lane highway. So we can handle so much more traffic. And, even in heavy traffic, we don't slow down. We can still run at highway speeds. We're not all jammed up like we are in the congested x86 world. So, really, it's a holistic thing between memory architecture, between internal bandwidth, and then just the compute capacity of all these independent threads running. To me, that's really a key, under the covers to why can we get to such high utilizations in highly virtualized systems? I mean, that's what we're designing for. And it is a system approach, not just building piece parts and throwing them together.
So this looks to me as if you're comparing a German Autobahn with a Katy freeway in Houston. To be quite frank, I love the analogy. Thank you very much.
Thank you. Thank you.
So you're saying that IBM owns the full infrastructure stack for power, like from the silicon and firmware up to the hypervisor and operating system. So how does that design together approach translate into real customer value?
Yeah, and that's a perfect question. And actually, if we go to my next chart, I'm kind of showing exactly that. And I mean, to me, power has all these great things, but this is the ultimate superpower of power, is what I call the one IBM stack. I mean, if you're in the x86 world, you maybe have an Intel or AMD socket, and sure, they're optimizing the processor and the packaging, but then they sell that socket to like an HPE or a Dell or a Lenovo, and then they have to try to make a system out of that. And then, oh, by the way, then you get your, VMware hypervisor or something else. And then, who knows what you're even running on top of that from an operating system standpoint. These people cannot communicate and optimize across these layers because they're in different companies. Whereas with Power and with IBM, all those things are done by IBM. So I'm in the processor, and I work directly with my packaging people, but I also work directly with the system people. So the whole discussion we just had around OMI memory, one of the things people ask me is, oh, why isn't everybody using this? Well, they would have to forge such comprehensive and detailed agreements on how to make it all work that you can really only do that well if you're all in the same company. So, I just walk down the hall and I talk to my system architect and I say, here's what we're going to do next time around. And we sort of sketch it out on a whiteboard. We figure it out. So you mentioned 300 patents. Well, that's just an occupational hazard. We get these inventions. It's just a byproduct of doing what we do when, we come up with these things that nobody else in the industry is doing. And we can do it because we're one IBM. The hypervisor level too. I'm always in contact with our hypervisor people. I didn't even touch on our security yet, but part of the reason our security is so incredibly good is we're able to just kind of put one big secure enclave around all of this. And so the hypervisor is, enabled by details right down in the silicon to get this perfect isolation, perfect protection. So really, I could go on and on about this, but the thing to think about is so many of the truly innovative things you can do, you can't just do them within your layer in the stack. You have to do them across the layers of the stack and bring transformative value across those layers. So that's, one of the most exciting things in my job, and it is Power's superpower. Power is so great because we have the whole stack and we can do these kinds of innovations.
Yeah, I think that is for sure the first takeaway for today. And I haven't heard this before, but like you're calling the one IBM stack as Power's superpower, correct?
Yes, yes.
Okay, well, that's awesome. I'll definitely write that one down. Udo, is there anything that you want to add to the Power superpower statement?
That's really cool wording. I never heard that as well. So power, superpower. I mean, there are so many aspects to highlight. We could highlight so many different things with different focus. So we talked about the security. We could talk about energy efficiency, but I think today's call is more about optimization. So let me talk a bit more about the superpower of optimization. Therefore, I want to concentrate on the flexibility advantages of the IBM Power and how the resource optimization takes or is in place. Can you give me my first slide? Okay. I mean, we have already since since many, many years that COD concept. So you activate resources by capacity on demand, core and memory. I'm talking about core and memory. And then there came the first pooling concept in, where you don't only activate on one server, you activate or can move activations from one to the other one, but you only buy it once. So you have a pooling of servers, but this is done by manual intervention. There's no automatic movement, so to speak. This was the first implementation. And then we have, on the other hand, another cool flexible thing, which is really unique to Power, is this dynamic LPARing or reconfiguration, of course, of memory and of I/O. So you can add and remove and adapt virtual processor attributes or complete virtual processors to the LPAR or from the LPAR away. So you can change these things, and you can even change attributes or devices. So if you need a new network, you touch that network, you can detach it, etc. Or you need a new fiber channel port, just add it to the LPAR. There is no need to go offline ever. The same for adding new, let's say you add a new 100 gig architecture to your servers and want to use it. There is no need to go down with your box. You just add that adapter into the running system and then doing the virtual adapter on top. And then we have an evolution, so to speak, to this Enterprise Pool 1.0. It's called 2.0. So it's not the marketing name, but it's the name everybody knows. It's the concept of, you have in this example system A and B, and usually there is a small curve below that 40 activations. You activate a certain amount of these 80 cores, let's say 40, which is sufficient for the workload. For system A, it's sufficient in system B. But what if you want to move that LPARs or VMs to the other system? You would need more resources to be activated. So if you want to do that all the time, back and forward, you would need more than 40 activations. And this is where the pooling concept comes in, Pool 2.0, where you activate, so a bit too far, you activate let's say you stack the curves above each other, and IBM is measure all the resources by a minute, what you consume. And if you, let's say in that example, we have a base activation in that complete pool of 56 cores. If you never reach them, and by the way, this is a stacking of the curves on the left-hand side, you are fine. If you go up that level, you get metered. So it's a pay as you go. You can prepay or postpay. There are different models. So this is a really cool story. And then IBM last year.
Is this pooling concept very often used by customers?
Oh yes, of course. It's we have many customers. I give you then an example of one customer who is heavily using it, but this is a local on-prem solution. Okay, can you click, Shane? And IBM added a even more flexible concept of that credits for consumption, which is not only valid for using it on-prem. You can also use them if you have making an enterprise savings plan with Power VS. So means it's a very flexible concept of where you're using your resources. It's really smart, I would say. This is new, so we don't have too much experience here because clients has to explore the need of the Power VS, etc. So make use of it. The left-hand one is established since Power 9, and we have many references, Lisa. May I show you one of them?
I was about to ask if you can please share a success story of like how organizations are running the critical workloads on IBM Power, especially using the platforms and to improve the resilience and modernization and all the buzzwords that everybody is using right now.
Yeah, you mentioned it in that customer story here of our good client, Bosch. Everything is in there. So there is a link, by the way, later on to the whole story. But I want to talk to that pooling concept here. So Bosch, probably everybody knows them. They are for consumer goods, mobility solutions, industrial technology, energy billing services, etc. So they are a huge player in the market worldwide. And this reference is based on Power 10, but it's also valid for Power 11 because in the meanwhile they started to adopt also Power 11, which was introduced last year, mid of last year. So what they are running on the top of that is a pooling concept, and the workload is one of the most important ones. It's SAP R3 on AX, it's S4 HANA on Linux, they hosting here about 60 countries and 400 locations. So they need a very flexible solution, and Power is really offering that flexible and dynamic, and pooling helped them a lot. So this is just one statement. They could also increase their utilization rate. So there are different aspects of benefits here.
That's pretty awesome. Thank you very much, Udo, for sharing this. And yeah, Bosch is a very, very well-known brand. And as far as I'm concerned, as IBM, especially in terms of supply chain shortages, IBM is still doing really a fantastic job sourcing hardware, still offering pretty good delivery times. But however, I think nevertheless, it is as workloads expand. Would you mind then elaborate a little bit why customers should still care about resource utilization, please?
Yeah, sure. I mean, you mentioned it. It's even when IBM is doing better than others, we still have price increase because the market is like it is. Yeah, and you want to max out your resources. So let us have a closer look to the IBM CPU layer. And by the way, whatever I tell now, hopefully I get an agreement of Bill because he's the expert, and I try to be the expert as well. The concept here, IBM has on Power has a layered architecture, CPU layered architecture, which is completely different from x86 because they own all the stack. So at top of the layer, we have our logical partitions, which represents an isolated operating system instance like AIX, IBM I, or Linux. Yeah. And then each LPAR presented a set of virtual CPUs, it's called VPs here, rather than access directly to the cores. So we have an abstraction layer here. So the operating system has no clue about the physical layer here. They deal with the virtual processors. And the virtual processors are managed by the hypervisor, okay? And the operating system itself, they schedule finally application threads on top of them. So, but they believe it's really CPU, and in reality, it's a virtual processor. So, and then comes the next layer in, it's so-called the simultaneous multi-threading. And the SMT finally allows to put more workload exactly in Power speak. It's the 8 threads Bill mentioned already on the same physical core. So we max out our utilization. We can put more throughput on the same resources. And the baseline below is then the physical hardware with cores dealing with execution, instruction, managing caches, memory access, etc., etc. So we have LPA on top, we have VP in the middle, we have SMT to execute the threads, and we have the physical cores on the bottom, okay? But to optimize this stack, you should have a monitoring, or you should configure and monitor your VPs and your SMT resources, okay? And why is that important? If an LPA gets a time slice on a physical core, the LPA should max out or use as much as possible from that core because it got on running, yeah? if the LPAR is not needing all the VPs, it's a good idea to give that back to the resources, to the hypervisor, to other LPARs that they can benefit. And therefore, there is a cool mechanism established. It's called virtual processor folding. And this folding is a real cool concept. Can you go to the next slide? It helps the hypervisor. I mean, if the LPAR is not using all the VPs because the workload is not enough running, it can fold them. And if they are folded, it gives the threads, or it gives the compute power back in the next cycle to other LPARs. So this behavior is available in AIX, in IBM I. Unfortunately, Linux is not that smart enough, because Linux runs also on x86 and they have no clue about that. It is a bit a different behavior, but it's also important to know how much the resources are used also in Linux, the SMT threads, because if they are not used really, you should lower your number of VPs that you get more out of the box. So concentrate workload on fewer cores, improve the cache locality, memory, reduce memory latency, etc. A lot of things. You have lower scheduling overhead for the operating system and the hypervisor, and you get back resources to your shared pool and to your Power Enterprise pool as well. So
I can definitely tell why you and Bill are such close friends.
Yeah.
This is very obvious. You're sharing the same love for a processor. That is
absolutely.
Awesome.
And well said, Udo, too. I confirm everything that you said. So
okay.
I'm not.
I got sweat here.
Yeah, this is very cool. And by the way, for the audience, in case you have questions, the Q&A is open. Please drop your questions and we'll address them at the end of the presentation.
Cool.
But Udo, one more question. I'm pretty sure you're working with customers that don't really know how to obtain visibility into the system performance, kind of to optimize these resources as their workloads expand, right?
Yeah, absolutely. I mean, you have different tools. That's an issue, by the way. You have the HMC. The HMC shows you information about the hypervisor usage or the LPAR usage, but the HMC is not giving you insights into the real operating system usage of the resources. And this is where I love, or clients of us love, to use BBQ. BBQ, we will hear a bit more about that product later on from Rosario, but yes. BBQ gives you exactly that insights in the usage of the CPU and memory. So we analyze the capacity entitlement, the VPs, and the thread configuration-wise, but also from the real usage inside the operating system. The same is valid for memory. So, and if you can analyze, you can optimize your systems to put more workload on the same servers, or to, let's say, optimize the needed configuration for a new box. Perhaps if you analyze that and find out, okay, if we do this or that tweaking, we could shrink our usage, and having a slightly smaller box to invest because the prices increases. So it makes a really cool story. And by the way, I mean, BBQ has so many different aspects, but from the sizing perspective, it's also cool that we also measure the I/O performance as well in parallel, and we can export. I mean, BBQ is not a sizing tool from the perspective that we also need some external data mapping, like what are RPERs the new boxes do have, or what if I would go to a different type of fiber channel bandwidth, etc. So, but the cool thing is we can export all the existing infrastructure data into a planning tool to model a new power server based on this data. So it's not that we type in something from tool A in tool B, we export it and have it in another tool. So that's really a really cool story, I have to say. And by the way, finally, we also get a complete planning, connectivity planning of the existing server, which is needed, by the way, when you want to attach a new one. You want to have this bandwidth connected to that ports in that fabric, and we need the same fabrics here, and we need the speed for the Ethernet, etc., etc. So this is a really cool tool, and yeah, I'm not only burned for power, I also burned for BBQ, to be honest.
Well, I cannot tell at all.
I'm gonna have a sip.
Well, yeah, you better have a sip. And I'm not sure, Udo, if you want to talk about your next slide that I think you have, or if I should bring Rosario to the game here, because let's see if she can be friends with you and Bill.
Yes.
I mean, we have now seen and heard, thank you very much, how BBQ solution can really provide visibility into how IT resources are used. And so, Rosario, question to you is...
You haven't seen one example. I brought in
okay,
one
go ahead.
one example.
Okay.
I'm not can make
Rosario,
advertisement.
they don't allow you in just yet.
Okay.
Yeah, I can't advertise the product only without any example. So let me give one example. This example is one view of BBQ. BBQ has allows, based on the data we collect, having different graph representations. This one is a special one. The upper one, the lower one is probably something everybody knows. The upper one in violet and green, etc., is so-called a tree map. And this tree map is really unique thing of BBQ. It shows you an object combined with a certain aspect. And if you see a picture, and I explain now what that picture shows you, you will immediately understand why this is cool. In this case, can you click once, Shane? In this case, we have that this complete green is the operating system environment, so it's the overall. And then in this aspect, we show virtual and logical CPUs in one as view, and the aspect shows how much it is used, the percentage it is used, and we have 4 VPs, and within that 4 VPs, you can count. These are 8 SMT threads. So means the big ones are the ones more used, and the small ones, the smaller they get, they probably not used at all. And and the percentage is also shown. It's a bit small here in that, but in reality, you see that quite easy. Can you click on it? So means we have 16 SMTs. By the way, this view, you can say it's a view of the last week, or it's a view from this time or that time. So it always represents the time you selected, okay? And we have, by the way, a dashboard delivered, which is always in place. You click that dashboard and you see that. So, and we have 16 SMT threads, and there is a 0%, which are not used at all. And then what does this mean? Can you click on it? No more than 16 SMT threads in total are used. So we can reduce. We know now they are not used at all, and we want to optimize. We can reduce from 4 VP SMT8 going to 2 VP SMT8, for example, because it will not change anything. The SMT3, the third and the fourth thread are same performance than the first ones. So this is one example where you can free up resources to the pool to put more workload, but you have to look in it. And this tool shows it easily to you.
Right. I like the context of the sizing of how you can immediately see the SMTs being used, which one is highly utilized or how many are utilized.
Correct. Wow, this is very impressive, Rosario. Now that you're speaking, let's bring you up to the game. You can join the boys team here.
Welcome.
She deserves it because she knows a lot about this. Would you mind and share how you or our customers kind of get the full picture across the entire infrastructure using BVQ monitoring?
Right. So as Udo was indicating, I want to first give you a high-level overview of how BVQ can be used to monitor the infrastructure. And then I will go into some details about other views that BVQ also offers. So BVQ really works with environments that use different platforms. So across the different IT layers, you can see the data path, how the data is performing, how each platform is performing from end to end, from power. So FlashSystems for organizations that are using FlashSystems, and also SAN and LAN as well. And be able to identify those bottlenecks very easily. So you can look at the data path starting from the power side or starting from the storage side. And it gives you that infrastructure visualization to be able to fine-tune those IT resources that Udo was mentioning, like the virtual processors. And you're also able to compare LPAR performance and determine if certain LPARs are running at high loads or low workload requirements, so that then you can consolidate workloads into a set of LPARs if needed. And also you can look at the storage performance and look at this demand over time, because that is very important. So you want to look at how workloads are changing and how they're performing over time. And this actionable visibility can be viewed in one way that Udo showed, very, I would say, with a lot of context. And those are for a lot of the technical teams that they definitely use that view. However, there's also a health status view and also ready to go dashboards that I will show you next. And you can validate that this impact in single dashboards that are ready to go with all the metrics necessary. So next slide.
Rosario, there are two questions about BVQ. One is an aspect question. Yes.
Okay, sure.
I think it's good to have them. They are really
I was
good
about
right
to
now.
ask.
What is the first question?
So first questions first. Can custom alerts be set up in BVQ, and how are those alerts set up and delivered?
Yes, alerts can be set up.
You're gonna get there anyways. But
Yes, definitely. So that's one level of the way that BVQ can show information. So if IT teams don't want to really go deep into looking at, for example, metrics or views, performance views, they can just set up the alerting, and you can have alerts for capacity, let's say for storage, in this case, FlashSystems, set thresholds to determine if certain pools are going over capacity or not. And also for the compute side to determine that if certain thresholds such as latency or response times are going up a certain level. But not only that, but also configuration. So I wanted to mention configurations are important to keep best practices in place as the workloads grow and expand.
So
what's the second question?
That means we deliver a lot of bunch of hundreds of alerts already
hundreds of alerts in different categories. They are already configured, and you can set them on or off as needed.
And
that is a question actually from the audience saying, with the number of aspects that can be monitored and the pressures that IT teams are working under with limited resources, Are we aware of any end user developing in-house automations in response to alerts?
Oh, in-house automations and bus alerts. You can also customize those alerts needed. So you can put together different metrics to determine certain how the workload is responding at a certain time. So you can set those customizations as well. So it's very flexible.
Okay.
The development team, it can also work on creating new alerts if those are necessary, because BBQ looks and obtains hundreds and hundreds of performance metrics from the power side, the flash, and the SAN.
Understood. Rosario, every organization right now talks about either modernization or tech refresh. They just all label a little differently, but they're all talking basically about the same thing. But it's obvious because they need to meet the demand for growth.
Right.
How can BBQ help them validate whether new hardware is truly needed or if existing IT resources can maybe just be optimized?
Right. So for IT teams that are starting or in the middle of tech refresh or modernization projects, and at the same time trying to navigate the supply chain disruption, they can easily be able to tune performance. So just a quick recap here, it just shows the enterprise platforms that BBQ supports, as well as ITSM, and be able to create tickets to automate the ticket creation to respond to issues. But moving on to the next slide. All right. So about fine tuning, this is where BBQ provides great value. And that's how our customers are using really BBQ to look at how, when their workloads grow and change over time, how can they tune those resources quickly, efficiently for optimal performance to deal with certain issues in the market that are going with pricing and et cetera. And BBQ can do that because it can look at the virtualization layer that Udo was talking about, and also the operating system layer. So in this case, I'm going to talk about the AIX layer. And it provides this dashboard, as you can see here, that shows all of the metrics that are necessary to immediately determine if virtual processors are running beyond entitlement, so that then the entitlement of those processors can be reduced in order to gain and be able to add workloads to a specific LPAR or to a system. It can also determine memory utilization, and then you can also compare the performance of LPAR. So this particular dashboard, it shows arrows that indicate the metrics that are necessary, but there's one specific metric, the over entitlement, that you can easily look at this metric and see if the virtual CPUs are over entitled or not, so that then you can go ahead and have an action item to lower the entitlement or not. And you can change these dashboard views from hours or even minutes to days, weeks, or months to look at how those workloads are changing. Next slide, please. And this is the BBQ end-to-end monitoring that I was mentioning that can help organizations also who are dealing with trying to resolve bottlenecks in the different IT layers to be able to pinpoint where that bottleneck is. It can be on the power side, virtualization side, storage, or SAN. And easily identify, and I'm pointing to peaks in workload utilization. For example, at the top, I'm looking at the first arrow, which indicates a adapter or virtual storage adapter that has been assigned to this LPAR. And there's a peak there, and then you can follow the data path to the storage, which is the middle area, and it shows the peaks in I/O and latency. And at the bottom, the SAN, it shows a peak in the switch utilization as well, the ports on the switch. So you can easily have a end-to-end view to determine where the bottleneck is happening. Next slide, please. And I want to show you here just details about the BBQ storage monitoring. So if you want to just look at the FlashSystem monitoring, this is what you would see. You can determine which volumes are overloaded, the LPARs that are impacting the volume utilization. And if you're running, let's say, the flash system grid, you can also be able to see the performance of each storage partition. Not only how many partitions are set up in the flash grid, but also how each storage partition is performing. And this dashboard specifically shows I/O rates and latency metrics for the flash system. Next slide. And this is the SAN monitoring. So I wanted to show you how you can easily see the metrics for the SAN, fiber channel switch data rate, frame rate, and even at the port level. And I believe there's one more slide, Shane.
Yeah, it is. And
okay.
I just saw the preview of this one slide, and I'm very, very curious about what you're going to say about that, because I was about to ask, I mean, we're talking about shortage, supply chain issues, whatnot. So how are we going to address the problem? Because I love talking about solutions instead of highlighting the problems over and over again. So, but I'm excited, Rosario, for that last slide here that you have.
Yes, with every BVQ engagement, we offer an IT infrastructure health check. And basically we've named it resource optimization check. So now it has an actual name. We've been doing this for many organizations where we engage our expertise with the solution for a one-time infrastructure analysis that it delivers the different views that I showed you. But not only that, you can have actionable items to be able to go back and make sure that the environment is still following configuration guidelines, and also be able to look where you can optimize for performance or bring back more resources so that you can run more workloads on, in this case, LPARs or storage pools or systems. And it can free up capacity as well to improve that performance. And
so it is a health check, right?
It is. It's definitely a health check. So in an hour, you can start. You can set up BVQ really easily. It starts scanning the systems, and in about 2 hours, you can start seeing findings. Ideally, you want to run BVQ during peak workloads. Okay, so peak workload times, so that you can have the best data. And we're offering this for participants today as well. So if you are interested, let us know and reach out.
Absolutely. And I was about to ask, I mean, this is hot off the press, so to say. So if you're interested in having a health check for your IT infrastructure, maybe you don't need to worry about global supply chain issues or price increases, because you realize you don't really need much more hardware. I mean, of course, you need some power systems, that's for sure. Bill, don't you worry.
But I want to add, Lisa, I want to add, Lisa, that as organizations are looking to modernize their infrastructure or expand, if they're already using power and flash and SAN, it's great to have a monitoring solution so that IT teams can go from siloed monitoring to that end-to-end monitoring.
Yeah. That is a very, very good point. Bill, Udo, anything that you want to add to what Rosario just said?
I just want to say I love this because, I mean, we build these fantastic systems, but sometimes it's helpful to have these additional diagnostics and these monitoring tools to help ensure that we're fully utilizing. We want to realize the full value of that investment. So I just love this, and I'm grateful that these improved, enhanced kind of tools are available, because the systems provide the most value when they're being more fully utilized, and that's what we build them for. So thanks for helping us get to that objective.
Great.
Absolutely. And Shane, if you want to jump to
the next slide,
say Bill promo slide, I want to see that one first. if you don't
Yeah.
mind.
Okay.
So to everybody in the audience, I mean, you noticed it today, but Bill is truly an outstanding individual from a personal perspective, but also from a professional perspective. He has been a speaker around the world. We had to postpone this webinar actually because he was speaking in India at some conference or whatever that was. I can highly recommend scan this QR code, access his YouTube video. You'll get the link in the thank you email after this webinar as well. But please make yourself familiar with what he does and why IBM appreciates him, hopefully as much as we do. So thank you very much to Bill. Also, on our website, you can find further information about BBQ, further information about the health check. Scan it or just go on svasoftware.com and reach out to us. We'd be more than happy to help, and on both sides of the Atlantic Ocean. So on the European side, where Udo is, it's 10:54 for him right now. It's crazy late. I have to say it's the same time for me because I'm in Hamburg right now as well. But we'll be back in Austin where Bill has taken them out for dinner. Very excited for it. Let me see if there's one more question in the Q&A. There's not. You have probably one more minute to post a question, and if not, let me take the opportunity and thank the wonderful speakers for today. Ladies first, Rosario, thank you very much. Very cool content, much appreciated. Udo, I know it's a federal holiday in Germany. Tomorrow, it was your birthday yesterday. Happy late birthday. So this is truly from a timing perspective, not ideal, but you still made it. This is wonderful. Bill, huge thank you to you. Much appreciate you. Stay tuned. And I promise we'll dine inside in August when I'm back.
All right. Thank you for the opportunity to be here. I always enjoy the chance to talk about what we do. So thanks.
Yes. And I mean, as you know, SVA is your biggest business partner globally. We'll collaborate even more in the future. Thank you very much for every participant. I hope you enjoyed your cheese, your wine, your crackers, your salamis, whatever you got. Have a lovely rest of the day. Thank you very much for joining, and see you next time. Thank you.
Thank you.
Thank you.
Bye.